NASA just dropped a new image from the most powerful telescope in space, and it is so very weird.
The James Webb Space Telescope has done it again. This time, it captured something astronomers had been searching for but couldn't find. 4 massive shells of cosmic dust spiraling outward from a dying star system. And what Webb revealed changes what we know about one of the rarest stellar systems in our entire galaxy. This is the Apep system, and here's what you need to know. Located roughly 8,000 light-years from Earth, the Apep system is named after the Egyptian god of chaos. And when you see the image, you'll understand why. What you're looking at are 4 serpentine spirals of dust, each one expanding outward from the center in the same precise pattern. The outermost shell is barely visible at the edges of Webb's image. Here's what's remarkable. Before Webb, ground-based telescopes could only detect one shell. Scientists suspected more existed, but they couldn't prove it. Every search came up empty. Then Webb turned its mid-infrared eye on the system. Everything changed. Yunuo Han, a postdoctoral researcher at Caltech and lead author of a new study, put it this way. Looking at Webb's new observations was like walking into a dark room and switching on the light. Everything came into view. So what's creating these shells? At the center of this system are 2 Wolf-Rayet binaries. These are massive stars nearing the end of their lives. They're extremely rare.
Scientists estimate only about 1,000 exist in our entire Milky Way galaxy, which contains hundreds of billions of stars. Apep has 2 of them. That alone makes it exceptional. These 2 Wolf-Rayet stars orbit each other once every 190 years. That's one of the longest orbital periods ever observed for this type of system. Most Wolf-Rayet binaries complete an orbit in 2 to 10 years. The next longest known orbit is about 30 years. During each orbit, the 2 stars pass close to each other for about 25 years. When they do, their powerful stellar winds collide. This collision creates and ejects enormous amounts of carbon-rich dust into space. And they're not doing this gently. The dust is being flung outward at speeds between 1,200 and 2,000 miles per second. That's up to 3,000 kilometers per second. Over the last 700 years, these repeated close encounters have produced the 4 shells we see today. But there's more. Webb confirmed something else researchers had suspected. There's a 3rd star in this system. This 3rd star is a massive supergiant, 40 to 50 times the mass of our Sun. It orbits the Wolf-Rayet pair from a wider distance. If you look at Webb's image and trace a V-shape from about 10 o'clock to 2 o'clock from the central bright point, you'll see a cavity, a funnel-shaped hole carved into each shell. That's the work of the supergiant. As it orbits, it slices through the dust like a knife, cutting the same hole in each expanding shell. Ryan White, a PhD student at Macquarie University in Sydney and author of a companion study, called it the smoking gun, proving the 3rd star is gravitationally bound to the system. All 3 stars appear as a single bright point of light in Webb's image, but the data tells a different story. So why does this matter? First, this is a one-of-a-kind system. Of the few hundred Wolf-Rayet binary systems observed to date, Apep is the only one in our galaxy containing 2 Wolf-Rayet stars of this type. Most have just 1. Second, Wolf-Rayet stars are where some of the earliest carbon in the universe was forged. Understanding how they behave and how they expel material helps us understand the chemical history of our cosmos. Third, these stars won't last forever. The 2 Wolf-Rayet stars used to be even more massive than the supergiant, but they've shed most of their mass over time. They're now estimated to be between 10 and 20 times the mass of our Sun. Eventually, both will explode as supernovae. Either one may also produce a gamma-ray burst, one of the most powerful events in the universe, before potentially collapsing into a black hole. Finally, there's still a mystery to solve. Researchers don't yet know the precise distance from Earth to the Apep system. That will require future observations. As Han noted, we solved several mysteries with Webb. The remaining mystery is the precise distance to the stars from Earth. The James Webb Space Telescope continues to reveal what was previously invisible. In this case, it showed us a chaotic dance of dying stars, carbon dust spiraling through space, and a system unlike any other in our galaxy. The Apep system is a reminder that even 8,000 light-years away, the universe is putting on a show, and Webb has a front-row seat. That's your space news update. If you found this interesting, hit subscribe. We'll see you next time.